Hi, quite a bit to get through in this video, so I'm just going to jump straight in. On or around about the 22nd of February last month, a few of you might have come across the story about the region around here, Los Angeles and California, and the topic that I was hoping that you might have come across would have been the one where there was an increase in carbon monoxide. I'm just going to go through it up to the present day or thereabouts. So, here we go. And you'll see in this region, a densely populated region where the parts per million went into the thousands. But before I do, I just want to give you an idea of, what the rest of the planet looks like on an average day where there isn't, an invasion of a lot of carbon monoxide. So we'll just take a few different regions. So here we've got 96 parts per billion, 93 parts per billion. Do one over the States, 136 parts per billion. And in the region where we're talking, California and Los Angeles, you can see that on this map it emphasizes the region by the discoloration, and we've got 375 parts per billion. So what I want to do is just run the video, or just run the modeling program, so we can see how it increased up to around about the 27th, and then swung out into the Pacific. So we're on the 23rd. We start to see in this region a gathering of more carbon monoxide. We're up to 709 parts per billion. We're going to go forward. On the 25th of February, you can see that region increasing now. Just take a reading. Okay, 485 parts per billion there, 410, 650, and I'll target the redder areas because that's where it's most dense, and that we're at that point there, 1,180 parts per billion of carbon monoxide. We'll continue. And you'll see the region increase. So there we're at the 26th, and we're at 10,489 parts per billion, as opposed to what the majority of the Earth has on an average day, 104 parts per billion out there, measuring in the Pacific. That's quite an increase. In this region, 4,516 parts per billion. And we'll just carry on to the 27th. We can see that the region is covered in a light cloud of carbon monoxide, even though these parts are per billion. It shouldn't be something too much to worry about, although there was some people reporting that it was difficult to breathe in that region. But you can see the plume increased. We're at the 28th of February. The 29th starts to dissipate somewhat, and the 1st and the 2nd, and we can see it now being blown out into the Pacific. The interest for me was whether we was possibly witnessing a early sign of sputtering. You can look it up. That's when solar rays or high energy protons come through the atmosphere, and that could be due to the fact that the magnetosphere could be changing and allowing more high energy particles to come through, and when it does, they collide with molecules, knocking off electrons and ions, and they get accelerated by the solar magnetic field, and they again speed up and crash into other molecules. And this is a process which has happened and is happening still to Venus. That's why a lot of the lighter particles on Venus, such as oxygen and things like that, have been removed, and mainly now an atmosphere of carbon monoxide is left. So I was just trying to see if we was witnessing, as there is a magnetic plume in this region, or the edge of the magnetic plume in that region, whether it was to do with sputtering. If we look on the temperature chart, we'll see that let's do it. Let's just do it. Get the temperature up. We'll see that it's on the verge, this region here anyhow, or at least is coming down. If I go on to these temperatures here, we're at minus 6.1 there, 7 degrees there. And you can see from the edge of the screen that these are sub-zero temperatures. If I just take a reading there, it's minus 39. And, I've compared this with magnetic overlays before, where these Arctic plumes are, of sub-zero temperatures, are where the magnetic plumes are of the Earth. So and we already, from the last video I put up, deduced that it was the America and the States and Canada region, or the Northern Hemisphere, was one of the regions where NASA's swarm mission has detected a weakening of the magnetosphere. So that's another reason why I thought, well, is this carbon monoxide possibly caused through sputtering of some regions? The other thing I wanted to get, I'll just leave it there. I didn't want to go too deep into this and bore the life out of it, but a lot of us haven't even taken into consideration some of the effects of a magnetic reversal could have on the atmosphere and changing the chemical makeup of the atmosphere. Just for instance, we've put away, probably some of you guys out there have done that as well. You've put water up, you've put food up, you've probably put ammunition up if you're in the United States, medical supplies. You may have thought you've covered your bases, but have you thought that during this magnetic reversal, the composition of air could change and how that could have an impact on yourselves? Now, quite literally, you might think, well, okay, oxygen is something I can't live without. Is there a way in which I could possibly manufacture enough for myself and family? Well, there is, and you'd be surprised that it wouldn't cost a lot, but you would need certain equipment, and through electrolysis you could produce possibly enough oxygen for yourselves. Now, how much oxygen are we talking about? Well, on average, there's 20% of the air in the atmosphere is a stock of oxygen. Now, I've done a little bit of looking up, because these are just the statistics that you just wouldn't remember in any case, such as how much oxygen then does people consume in a day. Well, just oxygen alone, it's 515 litres. That's not liquid litres, that's gas litres. So if you had a litre bottle of pop and you took the lid off it and just allowed gas oxygen to fill that litre up, that'd be around about a litre in volume of air. So you consume, in a 24-hour period, 515 of those bottles of oxygen, which works out, per person that is, per 24 hours, and that works out at 21 litres per person per hour. So, it's something that you can produce with electrolysis. You could produce a lot more pure oxygen. You wouldn't need pure oxygen. You wouldn't want to, I don't think you could survive on just an atmosphere of pure oxygen in any case. And the other danger of having an atmosphere of pure oxygen would be one of the lessons that was learned from Apollo 1, when there was a vast quantity of oxygen in the capsule, and as they flicked the switch, it caused an arc and pretty much set fire to everything in that capsule. So, how much then is 20% in parts per million in the atmosphere of oxygen? It's about 210,000 parts per million. That's around about 20% of the air. So if we was looking at over the regions of the Earth, and this modelling system did enable us to see the quantities of air sampled, quantities of oxygen in the air, we would see, on average, around most of the Earth's surface, around 210,000 parts per million. And remember, I'm saying parts per million, not parts per billion, as this modelling system was measuring the CO2 CO, carbon monoxide. So it gives you an idea when we start seeing even at levels of 10,000 parts per billion, it really isn't something to worry about, because there is air in that region, like in Los Angeles and in California region. So, okay, is it going to be a problem then? Are we going to lose oxygen? Well, oxygen is on a decrease. Just got some old data on this. Since 1991 to 2004, there was a 0.2% loss of oxygen in the atmosphere. So it is showing signs of depleting now. Is that due to the magnetosphere weakening? I don't think it's been concluded by any scientist yet. It could be. Is there a chance that the oxygen could deplete more so the closer we get to a magnetic reversal? I would say yes, because the magnetosphere will weaken, and that will allow more particles in. It will cause more sputtering reactions, and over that period of time that the magnetosphere is weakened or hasn't configured in a complete reversal, yes, it will allow for oxygen as well as other molecules in the atmosphere to be stripped off. So over a 13-year period, 0.2%, you might not think that that's a lot. If we just fast forwarded that by 5 times 13 years to 65 years, we would have a 1% loss of the oxygen. So 1% of the 20% that we've got in the atmosphere you'd lose over that period. But if the magnetosphere weakened further, that rate would increase, I would suggest, exponentially across a graph where we see the rate of the magnetic pole reversing. We would also see along that same line an increase in the loss of oxygen in the atmosphere. So it's an important thing, guys, and we take it for granted. The other thing is, just to put this into perspective, how important oxygen is to us right now, despite what we're doing to strip away trees in forests and things like that, and not really managing resources. We're burning oxygen in the cars. Can you imagine how many millions, in fact trillions of litres of oxygen 7 billion people on this planet consume? Let me just give you another statistic here. The Earth, if you measure it longitudinal, is 24,000 miles in circumference. If you measure it latitudinal, it's another 24,000 miles. That's why we got a perfect or almost sphere. Now, if you times 24,000 by 24,000, you work out the average square mileage of the Earth's surface. It works out at, I've got it on the calculator because I did it, 576 million square miles. You might think, whoa, that's a massive amount of space. But after that, the majority of that space is in liquid form, oceans. There isn't that much in land, but nevertheless, is an idea. I wanted to just give you. Let's just look at America. There's probably 300 to 350 million people in America alone. So if you give them 1 square mile each, there wouldn't be a lot left of this Earth's surface, would there? Now, think about it. There's 7 billion people on the planet, right? You could not give 1/10 of a square mile to each person. And the reason why we're going down this road is just to give you an idea of how much foliage, trees, etc., that produce oxygen there is, compared to the amount that not only do we consume as human beings, but the animals also consume, and the cars and the machinery or anything that burns any other fuel has to have oxygen in order to do it. Now, just think about that. And, not only are we in a time where we're consuming a considerable amount of oxygen out the atmosphere, but we're also in a time where the magnetosphere is weakening due to a magnetic pole reversal. So The main purpose of this video was to probably just put the idea there. Have you took on board the fact, or have you just even considered the fact that you might have to produce your own oxygen during a magnetic pole reversal? And what happens if the magnetic field doesn't come back up? And the reason why I say that is because this time around took 780,000 years. As you know, I always mention it, as opposed to 350,000 years. So, have you considered the fact that you might have to, for a period of time, should things get bad, have to produce enough oxygen for yourselves and your family? I'll tell you what I was going to do. I was going to put on the website, for those that don't know, there's a website now that is strictly related to magnetic pole reversals. The website address is poleshiftnews.com. There's no spaces in between poleshift news, so just poleshiftnews.com. Go up there. But what I was thinking of putting on that website was a learning centre, just explaining things like what we've talked about in this video today, sputtering, how the Earth could possibly lose its atmosphere over a period of time during a magnetic pole failure. There's also, I did mention this in the last video, I was going to put some diagrams of the different components of the magnetosphere and how the Earth produces its magnetic fields via the magneto in the core of the Earth. And a few other things. So, the websites can go on there. And if you'd want me to just build a simple device to show you that it's not particularly hard to create oxygen, basically, during the process of electrolysis, you take a water molecule or some water and you put two electrodes in there. But you have it separated in like a U tube, so that one electrode's up in one end of the tube, but the water is still connected, so that the conductivity between the two can still do its bit. And from one end you get hydrogen, from the other you get oxygen. Well, you could just simply have that U tube going through a wall in your house with a pipe on the outside, expelling the hydrogen. You could keep the hydrogen and burn it again with the oxygen in the same rates as what you broke it apart in the first place through electrolysis, and probably run something with that. Or you could just expel it because it's not something you want building up in your house whilst you're building up the oxygen in there, because, as you know, it's what powers the space rocket, the shuttle and other rockets into space. It's rocket fuel, basically. It's a highly explosive gas when mixed with oxygen. But you could still produce enough oxygen for yourself and other family members. And you'd probably do that. I mean, okay, if the grid went down, you'd use your solar panels or your batteries that you'd stored the power from your solar panels to it. What I'm saying is, if even small amounts of oxygen begin to reduce, you could notice how that could physically affect you. And, I just really wanted to mention this as something of importance. If we just look at Venus, it's got a main composition in its atmosphere of carbon dioxide or carbon monoxide, and that could quite easily happen on Earth. Have you thought about those things? The other thing, guys, is I just thought I'd briefly mention it. On the website, been doing a bit more work on that. I've not had the time this week to spend any time on the magnetometer station and getting the data logger working, but it's not on the back burner. It's still something I think about a lot. It's just having the time to afford to do it. But the point is here, guys, you have to get serious in supporting channels like myself and others. I know that there's another campaign there's quite a few campaigns going on YouTube with various channels, and it's not begging, for one. beggars earn a lot more money than I do believe some of the people that put the channels up. I mean, it was only in the paper yesterday that some guy was begging in some town, and he was making £800 a day. You know, you just put that into perspective. We're trying to deliver a service and information for people on this channel, and just to put it into perspective, over the last 2 weeks we've raised £20. It's not a lot at all, is it really? Considering most people would probably be paid that in a couple of hours, or, you know, you get the picture, don't you guys? It is important to keep some funding going in this channel. It provides time and equipment to build things to show you guys. It keeps the website running, and as well as other things, guys. And more than anything, it gives me a little bit of encouragement. And I really hate the fact that I have to mention this, but I've noticed if it's not mentioned, there just simply isn't no funding raised on the channel. So, you know, I'm going to put the link down there, and we'll see how it goes, guys. I do not want to put, and I'm not going to do it in any case, I'm not going to charge people for going on the website at all. The information is put out there so that everybody is not barred from it and has access to it. So, you know, like I say, guys, we really could do with some support from other people on the channel financially, and I'll put the link down there. I'm not going to go on anymore. Enjoy the rest of your week, and as always, guys, I'll say what I usually do. Bye for now.